Hello there, math fans. Today I'm going to make a video about a particular instance where someone in my family asked me a math question many years ago, and it was a matter of life and death. I'm being a little dramatic, more than a little dramatic. I'm completely embellishing. This imaginary number sometimes I get asked about why is it imaginary, and who the heck cares? What is wrong with you math people? But the story goes like this. I don't know how many years ago, maybe 10, maybe 15 years ago. My dad was building a sidewalk. He was a part of doing a development. I found a picture of it. I found a picture on the Department of Transportation, so I could figure out the radius. But he made this. He poured the concrete for this sidewalk as part of this development that was happening over here. And he called me with an interesting question that actually has some easy answers, but I'm mostly talking about what if you remember those answers and some interesting math along the way. And I don't even remember if I sent him very good information, and he probably didn't even use it. So watching this video is a complete waste of time. Anyways, here's my dad, and he was calling me saying, I'm going to pour this sidewalk, but like any new development, when you're always excited when you're someone buying a new house. You're like, hey, look there's a new development. Oh, great new house. I'm so happy that someone built this new house for me. And then you move in, and then 5 years later, someone tries to build a house next door, and you're not happy about it. Get off my lawn. Why? I have a nice spot. I don't want neighbors. And that's kind of a common thing with development, is people are happy when they get the new development, but they're not happy when something else comes along. And that's just a natural order of things. So why am I saying this? The gentleman in the house next door didn't want this development. Strongly didn't want it. And so he told my dad, if you come on my property, I'm going to shoot you. So I hope my dad's okay with me sharing this. But if you come on my property, I'm going to shoot you. I don't want you here. I don't want your development. Okay. It's just one of those things in life you have to deal with. So here's the problem. If you want to make a circle like this, and I've done this many times actually, this is in itself has a lot of applicability. If you can put a stake in the ground at the center of your circle, then you can attach a string to it that's 15 feet long. And then you can walk around the circle with that string tight, and it makes a circle. I've done that several times, like when I'm making a chalk line for part of a baseball field. We used to put a chalk line around the mound, or we'd put where the batter's boxes were, and sometimes we'd circle it out. So the normal way you'd put up your forms for the edge would be to figure out where the center is. But if he would have walked out here to the center, he would have been shot, and he would have been unhappy. Now, I don't think the guy really would have shot him, but I'm just saying this is the danger that he was under. So he couldn't go there, but he needed to form this up. Okay, so he had an interesting problem, which he had to get several points, and then they used this. I asked him, he said they used flexible wood there. So he needed several points around the edge of that circle. Now, those math people watching this, there's certainly many ways you could get those points. But my very first thought was roots of unity, because I've studied those and they're interesting. I've used them elsewhere, and they are solutions to this equation. And it gave me a way to recall some things very quickly. And I'm going to show some visuals in a second. But in particular, x squared equals 1 has no real solutions. The solutions we say are I and minus I. X cubed equals 1 has 3 solutions if you allow imaginary numbers. And they're these complex numbers. And it turns out you can figure out what they are based off of this. I had to look up how to pronounce this. This was a French mathematician and I still am going to pronounce it wrong because I've forgotten since the video started. Demouvre. I got it wrong. Anyways, but he proved this thing here about this and said the next root of unity, and this is not the root of unity. If you replace this with 2 pi over n, 2 pi over n, 2 pi over n, 2 pi over n, then this all simplifies to, is this what I wanted to say? Apologies. This simplifies to 1. Right, because it's 2 pi. So this simplifies to 1, and those are your roots of unity. So they are cosine, this would be 2 pi over 3 plus I sine of 2 pi over 3. Cosine of 2 times that, so 4 pi over 3 plus I times sine of 4 pi over 3. And then 6 pi over. Anyways, so this is this roots of unity thing. We often write it in terms of this what's called Euler's formula, and I'm sure I will make another video of that in the future. Leonard Euler's probably the most prolific and important mathematicians of all time, in my opinion. But they write it this way because it has nice geometric properties. So this little symbol I is actually quite useful. Particularly in geometry. So briefly to my answer, I can't remember what I told him. I think I computed several of these points, and I'm giving you a couple examples before I hop into some of the math. But I said, okay, make a straight line off of your sidewalk so far, go over and down this much. So over 2.35 feet, which I think I probably converted. I mean, my dad, there's nobody better at working with fractions if you've always been doing construction. Halves, eighths, 16ths, 32nds. Anyways, he can do that arithmetic better than anybody. But over 2.35 and then down, I guess it would be 0.19 feet. And then from there, I said, here's how much I want you to go over to the next one and down. And then I just kept going. But I got these points by remembering this stuff here. So now to some visuals. So here's a circle of radius 15. Those of you that have studied the unit circle know that you can use some trig. There's actually a triangle there if you think about it. I didn't make this ahead of time. But you can, this value, the x-coordinate is cosine of the angle. The y-coordinate is the sine of the angle. If the radius is 15, things don't change very much. You just multiply by 15. So let's watch it go. Ooh la la, look at that. Here we go. Those are the points. And when you're doing circular motion, you're going to use sine and cosine. Oh, that'll be another video down the line if anyone's still watching and YouTube doesn't kick me off. So what we'd like to do is plot several of these points, and there I've done it. Those are the roots of unity. Sorry, they're not the roots of unity because I'm using 15. If there wasn't the 15 there, they would be the roots of unity. Meaning these would be the solutions to x to the 11th equals 1. Visualized. Meaning if you take the x-coordinate, let's label them, this x-coordinate, plus I times this y-coordinate, we call this the complex plane, then that would be a solution to x to the 11th equals 1. Okay, those are the roots of unity. In fun, you can even inscribe a polygon, and that's a story for a different video where we could talk about approximating the value of pi and what is the area of that, and too many ideas for Dr. Lovelace. I don't know what to do next. And then let's keep going. Here's a bunch more and a bunch more. Those numbers are bothering me. Bunch more, a bunch more, a bunch more, a bunch more. Here it is with 50. I can't remember what in the one I just drew. Let's zoom in a little bit. I think maybe it was 40. Let's see the one I just drew. This is exciting. Okay, yeah, those are the points. So I computed these points, and I could have computed them other ways, but I immediately knew what to do because of the roots of unity. That I had studied those before. I needed them for lots of things. I've actually counted them in many places. So this is where things connect. I'm not saying that's the best way to do the problem, but this is my argument for studying math. You don't know where the connections will come into play. And these students that say, I'm never going to use this, you're right. You're never going to use it because you don't know it. Absolutely right. If you don't learn it, you're never going to use it. If you learn it, you may never use it, or you may save your dad's life. We don't know when we're learning things what we're going to use. But it's worth learning things, I think. That's the argument I'm trying to make. Okay, a few other comments. There's this book I read a long time ago, which I finally looked up, called George's Marvelous Medicine. That's also a good book. That's a Roald Dahl book. I love that book too. But Dr. Euler's Fabulous Formula. So this professor, I looked him up. He's written a few kind of popularized books about imaginary numbers. I don't know him or anything, but I'll have many ideas that he appears to have some similar interests to me, and that's this. It has to do with this expression. Here's my unit circle that students are always using in my class. The x-coordinate is cosine, the y-coordinate is sine. Fundamental for working with trig. So there we go. How complex numbers made me remember something that saved my dad's life. And then just to finish, I wouldn't be where I am now without the lessons I learned from my dad. We played lots of games. This is playing some games with my kids. Years ago, my love of games comes from him. Every time we would play a game, we would immediately try to change the rules and figure out, one, how to make them more fun, and two, how to cheat without anyone else knowing. And so that was very valuable for my math skills. This is a picture of the only time in my life where I was skinny, so I thought I would show that. Everything else, I was very fat. Here's a picture of him and my older brother and my kids. My dad is an avid WSU fan, and secretly I am too. I know. I don't know if anyone's listening at this point. I know I'm a teacher at UW, but I just have a soft spot for WSU sports. If one of my students is just playing a sport at UW, I'm rooting for that student. But beyond that, I'm rooting for WSU. Okay, and here he is holding my daughter. This is he introduced me to the sport of tennis, taught me how to be goofy with other people, which is a very valuable skill. He's very endearing when he's talking to others, and how he interacts. So he is a coach, cares a lot about sports, cares a lot about his family. So thank you, Dad, for taking me where I am. I am certain that you never thought I would be speaking in public. I was the quietest kid. Everyone was worried about me. And now I'm here at the University of Washington, and everyone's still worried about me, but for a different reason. All right. Love you, Dad. Thank you for this, and glad that you are alive.